Hello and welcome to my YouTube channel, The Intersection. In this video, I'm going to go through the steps of converting CFG into CNF. And these are the steps. We will introduce a starting variable. We will also eliminate starting variables producing any empty string, except the starting variable can produce an empty string. But this will not be allowed, so I'll show you how to eliminate this rule. Also, we will eliminate any unit of production, so such like variable A cannot produce a variable production B, and we will eliminate any useless symbols. These steps are from your book in the definition 2.8 of the context-free grammar in the Chomsky normal form. Okay, so let's start with an example. Let's say that you are given the CFG and you're asked to change it or convert it to CNF. Okay, let's go through the steps. The first thing is we have to create a new starting variable. It's not, and then it's going to produce A, S, or B, and A can produce S, A, B, and B can produce B, A, and not empty string. So now we can recognize that that's the only where we have an empty string, so we can assume B is nullable. If a variable called nullable, if it can generate an empty string. So B can generate empty string. So let's now take care of that empty string first. So let's do it beside it right here. So we're going to have an S not produces an S, and then S produces A, variable S, or B, and then A produces an S, or A, B. But now we recognize B, it can produce a string, empty string. So therefore, we add the A here and substitute the empty string for this B. And the final thing is the B can produce B, A, and then the empty, no, that's it. The empty string is gone. That's the second step. And S not is A, S, or B. And A is SS, B, or empty string. SS, or A, B, or A. And then the B is B, A. So now I need to get rid of the unit of production. I don't have any unit of production existed. So now I'm going to look for the other thing that is part of the condition, which is a non-terminal variables can only produce two non-terminal variables. And we cannot have a mix of terminal and non-terminal variables. So, of course, this is not in the right format. This is not in the right format. This is in the right format. So you can have a starting variable can produce a non-terminal one. Remember, that's in the form of A can produce non-terminal variable A can produce a non-terminal A, and so this is here I need to fix, and I need to fix this. So I'm going to introduce a variable U to produce an A. So, and then I'm going to introduce a variable V to substitute for the AA. I'm going to have an AA here. I'm going to introduce a variable X to substitute for AS. Okay, so let's see what happens when I do that. So S not can produce the A is U, and the AS is X, or B, or empty string. Remember, the starting position can produce an empty string. And then the second one is SS, AB, or BUB, or UB, uppercase UB. And then the A here is okay, because it can produce a non-terminal, one single non-terminal. And then the B will produce a U. I don't have something with the B. So let's do something with the B. Let's say R will produce a B. So the B will be R, and then the AA is V. So do these satisfy the three conditions? Yes. I have only non-terminal variables that S can produce. S can produce these UX, or S can produce only one single terminal or an empty string. A can produce two non-terminal variables or one single terminal, and B also. Now you have to include these equations into your answer. So let me fix that. So here's the final answer, cleaned up a little bit, and let's check it out. Let's see, do we have anything that we missed? We don't have anything we missed. Thank you for watching and have a beautiful day. Bye-bye now.